Let's calculate the frequency, and we're given the wavelength. All right, so let's use the equation. Speed of light is equal to the wavelength, which we will use lambda, times the frequency. Because it's asking us for frequency, that's nu, the Greek symbol, nu, let's rearrange that to solve for nu. All right, so we'll divide through by lambda, and we'll get the speed of light is equal to, the frequency is equal to the speed of light over the wavelength. All right, just plug the numbers in that were given. On your reference sheet, you'll given the speed of light is 2.998 times 10 to the 8 meters per second. Now you gotta hold on here, because the wavelength that's given, you don't want to just plug that in right here. Okay, rather you want to convert that into meters, or you can convert this into nanometers, which is, I just prefer turning nanometers into meters. Let's not mash apples with oranges. All right, so I'll do that down here. And you're gonna do so many of these, especially when you're talking about the wavelength of visible light. It's just conveniently expressed in nanometers, and you'll see that it's equivalent to 10 to the negative 7. Anyway, let's show our work. So that's going to be 676 nanometers, and let's use a conversion factor to get rid of nanometers. So put that on the other side of the conversion factor to cancel them out, and end up with meters. So one conversion factor is a nanometer is equal to 10 to the negative 9 meters. All right, now there's other conversion factors, but just want to make sure those are equalities. That's what conversion factors are. All right, so that's going to give you 676 times 10 to the negative 9 meters. All right, if you move that over twice, you get 6.76 times 10 to the negative 7, which is what I was saying earlier. A lot of times you can express it in scientific notation with times 10 to the negative 7. At least the visible light range. All right, so now why do we do this? Oh, right, because we need to match apples with apples. So we want to cancel out the meters, right? So we want our wavelength in terms of meters. So 6.76 times 10 to the negative 7 meters. All right, so now we can see the meters cancel out. We're left with units of hertz, or per second. Now we're going to need a calculator. Finish this off. All right, 2.998 times 10 to the 8 divided by 6.76 times 10 to the negative 7. And we're expecting a very large number because these things move literally at the speed of light. They move really, really fast. So frequency means they're going to be very, very frequent. It's going to pass through. All right, so it's we need 3 significant figures because of our the only measurement we're given is the 676 nanometers, which has 3 sig figs. Our answer is going to have 3 sig figs, 4.43 times 10 to the 14 hertz. All right, that, by the way, if you want to use prefixes, that's 443 terahertz.